Alright, so last lecture we've discussed about boiling point elevation and freezing point depression. Before we move to vapor pressure lowering and osmotic pressure, let us first recall the relationships, no? Sabi natin, the boiling point of a solution is always greater than the boiling point of the pure solvent. So these are your colligative properties, no? You have boiling point elevation, freezing point depression, vapor pressure lowering, and osmotic pressure. And again, when we talk about colligative properties, we are only concerned with the number of solute particles dissolved in a particular solution. So basically, ang tinitingnan mo pag colligative properties is gaano ba kadami yung solute particles na nakadissolve dun sa solution mo. Wala tayong pakialam dun sa nature ng particles na yon. Ang concern natin is gaano ba sila kadami. Okay, so pag sinabi nating solution, no, this is comprised of your solute and solvent. So in this case, the relationship of your boiling point, no, with the solution versus the pure solvent. Say for example, ang pure solvent mo is tubig, nagpakulo ka ng tubig sa bahay, let's say it's pure water, it will boil at 100 degrees Celsius. But if you add salt to that water, to that solvent, no, it becomes now a solution, the boiling point increases. Why? Because there are now already solute particles dissolved in that solution. That is why the boiling point of solution is greater than the boiling point of your pure solvent. You will need a greater amount of energy, no, for this solution to boil. How about freezing point depression? So the freezing point of the solution is always lower than the freezing point of the pure solvent. Ayan. Okay? Now we go to vapor pressure lowering. So vapor pressure lowering, the vapor pressure of a solution of a non-volatile non-electrolyte is always lower than the vapor pressure of the pure solvent. Please take note, no, na yung mga sinosolve natin ever since we started solving for boiling point elevation is on non-electrolyte components pa lang, no? That's why we still don't have the Bantoff factor. Though, pag electrolytes, parehas lang din yan sila ng formula. Ang nagkakaiba lang is si electrolyte, we already consider the Bantoff factor. The Bantoff factor, I will discuss, no, after I have discussed all the colligative properties of our solution. So again, pag vapor pressure lowering, ang vapor pressure daw ng ating solution ay laging mas mababa kesa sa vapor pressure ng ating pure solvent. Ayan. So yan lang yung relationship nila, no? It's very easy. And this statement is self-explanatory. Now, we move to the computation, to the calculation. So if you want to compute for the vapor pressure lowering, you use Raoult's law, no? So this is the formula for Raoult's law. So Raoult's law, this is a law of thermodynamics, no? It was established by a French chemist. I couldn't remember already the first name. I think it's Marie, no? No, it's not Marie, it's Françoise ata. Basta ang surname niya is Raoult, no? Kaya siya Raoult's law, no? So ang sinasabi ni Raoult's law states that the partial pressure of each component of an ideal mixture of liquids is equal to the vapor pressure of the pure component multiplied by its mole fraction in the mixture. Now, say for example, you have here a solution, no? You have component A, component B, and component C. Ang sinasabi natin na partial pressure is the pressure of the components, of the individual components. Partial pressure is equal to the pressure of the individual components. Ayan. So, sabi ni Raoult's law, if you want to get the partial pressure of these individual components, all you have to do is multiply the mole fraction and the pressure of that pure component. So P1 here is the partial pressure of any component. And here, your mole fraction here it is the mole fraction of your solvent. And your P1 naught, basta nakita nyo yung symbol na naught, that is for the pure, no? This is the pressure of the pure component. Pure component. Okay. But take note, Okay, so P1, vapor pressure of your pure solvent. Ayan, pure component, pure solvent. X1 or mole fraction 1 is the what? Mole fraction of your solvent. So, if the solution contains only one solute, ayan, I'll explain this one, no? Mole fraction 1 is the mole fraction for your solvent. Mole fraction 2 is the mole fraction of your solute. Okay? So now, since we're talking about colligative properties, and pag sa colligative properties, ano yung kinoconsider natin? Ang kinoconsider natin is the number of solute particles. So dapat ang i-compute natin, dapat na nasa formula natin is the mole fraction for your solutes. And take note that the mole fractions, they are all equal to 1, no? Pag pinag-plus-plus ninyo yung mga mole fractions ninyo, it should be equal to 1. So the mole fraction of your solute and the mole fraction of your solvent should be equal to 1. Now, if we're going to use the mole fraction for the solute, the formula becomes like this, no? Wherein your P1 naught minus P1, that is equal to your vapor pressure lowering. So, the change in P symbol, this is your vapor pressure lowering. Ano ang ibig sabihin ng vapor pressure lowering na yon? It is the difference between the two pressures, the pressure of your, what do you call this? The pressure of the pure component and the partial pressure. Okay? So now, so this is the formula that we are going to use. Delta P is equal to X2 P1 naught. Sinubstitute lang ito, no? This was only substitute to X1. It was only substitute to X1. So, pakita ko na lang. Sige. P1 is equal to 1. P1 is equal to mole fraction 1, P1 naught. And since we want to get for the mole fraction of the solute, because we are accounting for the solute particles, kasi colligative properties ito, so the mole fractions, when they are added together, they are equal to 1. So, let's substitute 1 minus this one. 1 minus the mole fraction of your solute to this one. Sinubstitute lang po yan dito, no? P1 is now equal to, ito na, X1 kasi is equal to this term. So, 1 minus the mole fraction of your solute times P1 naught. Okay? So, now you have to distribute this one, no? You have to distribute this one. So, P1 naught is now equal to minus X2 P1 naught, ayan, is equal to P1. So, you transfer this to the left-hand side of the equation. So, it's now P1 minus P1 naught is equal to negative mole fraction ng solute P1 naught. And this term shouldn't be negative. So, you multiply both sides by negative 1. So, P1, so P1 now is equal to plus P1 naught is equal to the mole fraction of your P1 naught. Now, this one, ayan, this one kasi, if you multiply this by negative 1, this becomes positive. Kasi negative times negative, it's positive. However, this becomes negative also. This becomes negative P1 naught. So, to rewrite the formula, it becomes P1 naught minus P1 is equal to mole fraction ni solute P1 naught. So, dyan galing yung equation na iyan. So, again, di ba, I multiplied this by negative 1 kasi nga, this term is negative and it shouldn't be negative. So, negative times negative, it now becomes positive here. Tapos, this one, initially, this was negative, and negative times negative, it's positive. However, this term, it's positive, and positive times negative, it becomes negative. Kaya siya naging ganito. I just rewrite the equation, no, para maging ganito siya. Ayan, and this term right here, this term right here, that is your delta P. That is your vapor pressure lowering. Ayan. Very easy, very easy. Okay, so you can either use this formula or this formula when you solve for the vapor pressure lowering, no? So if they are looking for the vapor pressure lowering, that is delta P, if they are looking for the pressure of the pure component, you'll use this formula kasi naka-elaborate na dito yung P1 naught, which is for your pure component. Okay, so now here, this X2, this is the mole fraction of your solute. Again, why did we look for the mole fraction of the solute? Because this is a colligative property. And again, when we talk about colligative properties, we are accounting for the number of solute particles. So this is for example number 1. Though may sagot na siya, I'll still answer it, no? So calculate the vapor pressure of a solution made by dissolving. Okay, again, calculate the vapor pressure of the solution made by dissolving 218 grams of glucose. Binigay na yung molar mass. Dinisolve daw ito sa 460 ml of water. At 30 degrees Celsius. Do we need the 30 degrees Celsius? No. Because we're solving for the vapor pressure. What is the vapor pressure lowering? So you are asked, what is the vapor pressure lowering? The vapor pressure of pure water, so when you see this term pure, that means that is P1 naught. Automatic ha? Siya yung may naught kasi siya yung pure. Is at 31.82 millimeter mercury. 31.82 millimeter mercury. Assume the density of water is 1 gram per ml. Okay. Now, you are given the density of water, it's 1 gram per ml. Lahat yan magagamit ninyo later, no? So, calculate the vapor pressure of the solution and the vapor pressure lowering. Okay? So, how do you solve this kind of problem? Calculate the vapor pressure of a solution made by dissolving 218 grams in 460 ml of water, 30 degrees Celsius. What is the vapor pressure lowering? The vapor pressure of water at 30 degrees Celsius is 31.82 millimeter mercury. Assume the density of water is 1 gram per ml. So you are looking for the vapor pressure of the solution and the vapor pressure lowering. So if you're going to look at this formula, asan yung vapor pressure ng ating solution? Ito yung sa pure. Basta may naught, pure yan ha. Let's rewrite the formula. P1 naught minus P1 is equal to the mole fraction of your solute, P1 naught. Okay, so you have the P1 naught was given to you in the problem. It's 31.82 millimeter mercury. When it comes to the units, ang mahalaga lang dito, magkaparehas yung pressure, no? Kasi si mole fraction, it's unitless. So, if your P1 naught is millimeter mercury, dapat si P1 mo, it's also millimeter mercury. So, kung atmosphere, si P1 naught, si P1 dapat ay atmosphere din. So, you are given the P1 naught. You are looking for the vapor pressure of the solution and the vapor pressure lowering. You can only solve for the vapor pressure lowering if you know the vapor pressure of your solution. And this is the vapor pressure of your solution. Okay, so you're solving for this one. Now, were you given the value for the mole fraction? No. But you were given the grams of your solute and your solvent. Again, this mole fraction is for your solute. Sa solute mo yan. So, i-identify mo muna kung sino si solute at si solvent mo. So, here in this problem, the solute is glucose and the solvent is water. Okay? The solute is glucose. So, glucose. And this is your solvent, water. Okay? Now, what is the formula for the mole fraction of your solute? What is the formula for the mole fraction of your solute? It's the mole fraction of your solute is equal to the mole of your solute, ayan, over the mole of your solute plus the mole of your solvent. Kung nalilito pa din how we get the mole fraction, how we do the formulas for the mole fraction, kung kanino yung mole fraction na hinahanap mo, siya po yung nasa numerator. So, solute po yung hinahanap natin kasi kaya po si solute yung nasa itaas. Sa baba, total number of moles. Dalawa lang naman yung components ng ating solution. Solute and solvent. In this case, glucose and water. So, i-rewrite ko ha para mas makita ninyo. So, mole ng glucose, C6H12O6 over the mole of your glucose, C6H12O6 plus the mole of your water. Okay? Madali lang po, madali lang po. Now, can you substitute 218 grams and 460 ml to this formula right away? Hindi po. Bakit po? Kasi po hindi pa po sila nakamole. So, you have to convert this to mole first. So, the glucose, so the mole of your glucose, mas madali na tong computein kasi binigay na niya yung molar mass. So, the molecular mass is 182 gram per mole. So, what is the conversion factor? The conversion factor is now 1 mole of your glucose is equal to 180.2 gram per mole. Ayan. So, let's solve for the mole of your glucose. Ayan, we'll solve for the mole of your glucose. Start with the given. Ano yung value na given sa atin? 218. So, 218 grams of your glucose. Okay. Sa baba, sorry, wala na palang per mole ito. Bakit? Kasi nandito na yung mole. Nandito na yung mole. Okay? So, sa baba, yung grams, 180.2 grams. Sa taas, 1 mole of your glucose. So, cancel, cancel. So, 218. Ayan. Let me get my calculator. Sorry. It's not working. Wala na ata siyang battery. Ayan. So, 218 divided by 180.2. That is 1.21 mole. Ayan. Meron pala dito. Sorry, guys. So, 1.21 mole ng ating glucose. Now, how do you get the mole of your water? Eh, ang binigay sa'yo ay ml. Pero binigay kasi sa'yo yung density. So, you use the density to get the grams of your water. So, for the mole of your water, you are given ml, 460 ml, and you were given the density. That is 1 gram per ml. So, 1.00 gram, multiply it per ml. Para mag-cancel yung ml, you get the grams. So, 460 times 1, that is only equal to 460 grams. Now, you can now convert this to mole kasi naka-grams na siya. What is the molecular weight of your water? So, H2O, you have 2 atoms of hydrogen, 1 atom of oxygen. Multiply this by its atomic weight in the periodic table. This is 1.01. And this is 16.00. If you use 15.99, it's okay. Maliit lang yung discrepancy. So, the total of this is 18.02 grams per mole. Now, what is the conversion factor to convert the grams of your water to mole? So, 1 mole of water, di ba, equal lang yun sa grams ng ating molecular weight. So, 18.02. Now, start with your given. Your given now is 460 grams. So, 460 grams of water. Ayan. Sa taas, 1 mole of water. Sa baba, 18.02 grams. Para mag-cancel yung ating grams. So, 460 divided by 18.02, you'll get 25.5. 25.5 mole of your water. Now, you can substitute this to the formula of your mole fraction. This is the formula for the mole fraction of your solute. Let me rewrite it here para mas makita ninyo. Solute ang hinahanap natin ha, mole fraction ng solute. So, ang solute mo ay si glucose. Ayan. Now, this is equal to the mole of your glucose over the mole of your glucose plus the mole of your water. So, now, substitute na natin. Ano yung mole ng ating glucose? What was the computed mole? It's 1.21 mole. So, here, 1.21 mole over 1.21 mole plus the mole of your water, 25.5 mole. Again, your mole fraction is unitless because all these moles will cancel. So, the mole fraction of your solute is 0.0453. Now, let's rewrite the formula for vapor pressure lowering. That is P1. What is again the formula for your P1? Okay, sorry. It's P1 naught. Tama? minus P1 is equal to the mole fraction of your solute times P1 naught. Is my formula correct? Let me check. Yes, okay, it's correct. Now, look at the values given to you in the problem. You've already solved for the mole fraction, that is 0.0453, and you have the P1 naught. It's always given in the problem. Here it is 31.82 millimeter mercury. Si P1 naught, laging binibigay yan sa problem, no? The vapor pressure of your pure solvent is always given in the problem. Now, you can now solve for P1. Diba? You can now solve for P1. So, solve for P1. Kasi P1, again, this is the vapor pressure of your solution. We can now solve for this term because you already have the mole fraction of your solute and the vapor pressure of your pure solvent. Okay? So, now substitute 31.82 millimeter mercury minus P1 is equal to the mole fraction of your solute, 0.0453. Again, wala pong unit si mole fraction ha, unitless po ito. Times 31.82 millimeter mercury. So, ano ang unit ni P1? Millimeter mercury din, no? Kasi parehas lang sila dapat ni P1 naught. So, multiply 0.0453 times 31.82. That is now equal to 1.44 millimeter mercury. So, equal P1 minus 31.82 millimeter mercury. So, now you can solve for P1. So, you transpose this term to the right-hand side of the equation. So, negative P1 is now equal to 1.44 minus 31.82. Minus 31.82, you get, this is 30.39 millimeter mercury. Negative P1. So, now you multiply both sides by negative 1 to get, because this can never be negative, no? This term can never be negative. So, multiply it by negative 1. This becomes P1 is equal to negative 30.39 millimeter mercury. So, what is now the change in, what is now the vapor pressure lowering? So, the vapor pressure lowering is equal to P1 naught minus P1. So, change in P is equal to what? This is equal to 31.82. That's given in the problem. Minus 30.39. So, 31.82 minus 30.39. The answer is 1.43 millimeter mercury. Ayan. So, if you use 15.99, I think you'll get 1.54 millimeter mercury. So, kapag ang discrepancy sa computation ay 0.01 lang, 0.02, it will be accepted, no? Kasi perhaps you used a different, what do you call this? You used a different value for the atomic weight of the solution. Atomic weight of your components. Ayan. Any questions? Wala na. Okay? Or kasi minsan yung iba, they only use 2 decimal places for each step. While others would use the full value sa calculator, yung mahaba 0.3334555. It actually affects the computation. So, in my case, I actually used the full values. That's why I got a lower one, 1.43 millimeter mercury. But if your answer is 1.44 millimeter mercury, it's okay. Basta nga ang discrepancy is 0.01 or 0.02 lang, wala tayong magiging problema doon, ano? Okay, now let's go to the osmotic pressure. Okay, if you're going to look at these two membranes, this figure, it has a semi-permeable membrane, no? It has a semi-permeable membrane in the middle. So, when we talk about osmosis, this is the selective passage of your solvent molecules through a porous membrane from a dilute solution to a more concentrated one. So, ang movement ng ating, what do you call this? Ang movement ng ating solvent pag osmosis is papunta sa concentrated, no? Galing ka dun sa dilute, papunta ka sa concentrated, which makes sense, no? Kasi i-dilute ni solvent yung concentrated particles na iyon, no? So, osmosis occurs when two solutions containing different concentrations of solute are separated by a selectively permeable membrane. So, in this case, at figure 1, at this figure, kung papansinin ninyo, parehas sila ng water levels. Pero dito sa second figure, mas mataas na dito. So, we can infer, no, that this side is more concentrated kasi ang solvent natin ay tumawid doon sa semi-permeable membrane papunta doon sa more concentrated, kaya nga po mas tumaas yung water level dito kasi si solvent pumunta doon sa more concentrated. So solvent molecules, they pass preferentially through the membrane from the low concentration solution to the solution with a higher solute concentration. Okay, so yung passage ng solvent molecules, magtutuloy-tuloy yan. It will continue until equilibrium is attained, until equilibrium is reached. Okay, I hope that is clear. So what is osmotic pressure? Basically, osmotic pressure is the pressure required to stop osmosis. You want to stop osmosis? That's osmotic pressure. Okay? Now, osmotic pressure is the minimum pressure needed to prevent the inward flow of solvent across a semi-permeable membrane. Sa madaling sabi, this is again the pressure you need to stop osmosis. So what is the formula? The formula is this. Ayan. This is pi, right? Pi is equal to MRT. So osmosis na tayo, no? Pi is equal to MRT, wherein M is your molarity. What is again the formula for molarity? It is moles of solute over the liters of solution. And your R is the gas constant. What's the value for your gas constant? This is equal to 0.0821 liter atmosphere per mole Kelvin. Dapat memorize po ito ha. T is for the temperature and it should always be expressed in Kelvin. So in a cell, osmosis is actually applied, no? So I know you are already familiar with this because it's already discussed in your biology. So, isotonic solutions, pag isotonic solutions, yung concentration sa loob at labas ng cell, equal lang sila. Pag hypotonic, the concentration inside the cell, it is greater. That is why your solvent molecules will enter the cell, no? And when it enters the cell, minsan nagsuswell siya, no? It will eventually burst, no? It will eventually burst. Kapag hypertonic ang solution, mas mataas ang concentration outside ng cell kesa sa loob ng cell. So, ang tendency ng water, ng yung solvent mo, is to escape the cell, no? To go out of the cell. Kaya yung cell mo is nagsishrink. Nagsishrink siya kasi lumabas na yung solvent. Ayan, I hope that is clear. Specifically, the solvent here is water, okay? No, kasi cell ito. Okay, so you have isotonic, hypertonic. So again, pag hypotonic, pumapasok yung water papaloob sa cell. Kapag hypertonic, lumalabas yung tubig palabas ng cell. So let's have this example. Although meron na siyang sagot, okay lang, sasagutan ko pa rin to elaborate, no? So we have the average osmotic pressure of seawater is about 30 atmosphere. This term, guys, is your osmotic pressure, okay? So this term daw, the pi is equal to 30.0 atmosphere. This 30 atmosphere is true at 25 degrees Celsius. Ayan, calculate the molar concentration. So, molar, that's molarity. So, molar, we are looking for this one of an aqueous solution of sucrose that is isotonic with water. So, now, if you're going to look at this formula, actually, lahat ng terms ng kailangan mo, nandyan na. Ito yung nawawala, meron kang osmotic pressure, meron kang temperature. Si temperature, ko-convert lang to Kelvin, so plus 273. If you use 273.15, it's okay. Maliit lang yung discrepancy niyan. So, 25 plus 273, it's 298 Kelvin. Now, what is the R? The R is the gas constant. And dapat memorize ito, no? This is 0.0821 liter atmosphere Ayan, that's too big. Let me make it small. Liter atmosphere per mole Kelvin. Now you're asked to solve for the molarity. Manipulate the equation. Isolate the term for molarity. Pi is equal to molarity RT. So divide both sides by RT para maiwan si M sa isang side. Okay? So, M is now equal to pi over RT. So, if you substitute those values, magiging ganito yung itsura niya. So, you'll see the cancellation of units. Since this is molarity, one way of checking kung tama ba yung problem solving natin is that yung hinahanap natin na units, sila yung naiiwan sa calculation. So, molarity class is mole per liter. So, if this is mole per liter, dapat ang maiwan dito ay mole per liter din. So, ATM will cancel. Kelvin and Kelvin, this is liter per mole. Pero magre-reciprocate yan eh. So, magiging mole per liter siya. So, either you can write 1.23 mole per liter or M for molar, parehas lang po iyon. So, very easy. Very easy. Now, for the calculations, we'll have a separate video for that. For now, our goal is for you to grasp the concepts. If you have any questions, post them on the discussion forum or post them under this video. On the next lecture, I will be discussing how we solve for electrolytes considering the Van 't Hoff factor. Okay, that's it. Have a good day.